Hello! Welcome to the new section of the course, Concurrent Collections. Through the videos in this section, you will learn how to use some Java collections in your concurrent applications. These include non-blocking deques, blocking queues to be used with producers and consumers of data, and order elements by priority. We will also look at blocking queues with delayed elements, non-blocking navigationable maps, and non-blocking hash tables. We will learn about variables stored in fields marked with the volatile keyword, atomic variables, and atomic operations on the fields of individual classes. Now we move on to the first video of this section that deals with using non-blocking thread-safe deques. In this video, you will learn how to use a non-blocking deque in a concurrent program. A deque is a data structure similar to a queue, but in a deque, you can add or remove elements from either the front, head, or back, tail. Non-blocking deques provide operations that, if not done immediately, for example, you want to get an element from a list but the list is empty, throw an exception or return a null value depending on the operation. Java 7 introduced the ConcurrentLinkedDeque class that implements a non-blocking concurrent deque. We are going to implement an example with two tasks, one that adds thousands of elements to the deque and one that removes data from the deque. So, create a new Java project and give it a name of your choice. Create a class named AddTask and specify that it implements the runnable interface. Here, import the Java library for this class. Now, declare a private ConcurrentLinkedDeque attribute parameterized by the string class named list. Then, implement the constructor of the class to initialize its attribute. We will implement the run method of the class. This method will have a loop with 5,000 cycles. In each cycle, we will take the first and last elements of the deque, so we will take a total of 10,000 elements. We create a class named PollTask and specify that it implements the runnable interface. Here, we need to import the java.util.concurrentLinkedDeque library for the class. Inside the PollTask class, we declare a private ConcurrentLinkedDeque attribute parameterized by the string class named list. Next, implement the constructor of the class to initialize its attribute. Here again, implement the run method of the class. It takes out 10,000 elements of the deque in a loop with 5,000 steps, taking off 2 elements in each step. Now implement the main class of the example by creating a class named main and add the main method to it. Here, import the Java library and the class. Inside the main method, create a ConcurrentLinkedDeque object parameterized by the string class named list. Next, create an array of 100 thread objects named threads. Next, add this code. Here, we create 100 AddTask objects and threads to run each one of them. Store every thread in the array created earlier and start them. Then, add this block of code. Here, we wait for the completion of the threads using the join method. We print a line to the console showing us the size of the list. Create 100 PollTask objects and threads to run each one of them. Then store every thread in the array created earlier and start them. After that, wait for the finalization of the threads using the join method. Finally, we write the size of the list in the console. Now run the program, and you can see the output of the program. Here, we use the ConcurrentLinkedDeque object parameterized by the string class to work with a non-blocking concurrent deque of data. So, we have used the ConcurrentLinkedDeque class successfully.